Good afternoon. This is the Getting Started video for Astronomy 2002 Fall Semester, online section 0W60. I'm the instructor, Thomas Brickner. I'm a theoretical astrophysicist. What that means is I study black holes and quantum field theory in the early universe, i.e. the Big Bang theory. Uh, the course description for this class, Astronomy 2002, is a descriptive survey of solar system, galaxies, and universe, physical properties of stars, HR diagrams, stellar evolution, black holes, and neutron stars. And we'll be covering all of that stuff at some level of detail. One of the things I want to share with you is an interesting NASA-related bit of work or a NASA-related emphasis that ties the whole class together. Um, here's a picture of Katherine Johnson. Uh, if you've ever seen the movie Hidden Figures, you'll know that she was very famous at NASA for calculating spacecraft trajectories. Whatever needed to be done, she could do it. And this is a picture of the real Katherine Johnson just a few years ago. The question, what is NASA up to with all these spacecraft launches, landing a man on the moon, and all that stuff? Well, it just so happens that some of NASA's exploration, specifically to a comet, is going to tie our whole class together. Now, let's take a look at the story in terms of what we can see in the sky. If you get up on Monday morning, before dawn, about 4 a.m., and if you look to the east, this is what you'll see. You'll see, if the sky is clear, you'll see a bunch of constellations. You'll see up near the top, you'll see the Pleiades, also known as the Seven Sisters. In Japan, they call it Subaru. And it's easy to see because first of all, it's above the horizon, and the horizon could be a little bit hazy. But the Pleiades will be up above the horizon, and it looks like a patch of light. Even if the sky's not totally clear, you can see it sometimes as a patch of light. If you're up in the mountains out west, it would be clear as a bell. You'd be able to count, if you have good eyeballs, you'd be able to count individual stars. Anyways, Pleiades, it's pretty easy to see those, and before dawn you'll see them. Another one down here is the star known as Betelgeuse, and you may have read about Betelgeuse in the news lately. It's a red supergiant star in the constellation Orion, and it's been oscillating in brightness. And we're wondering if that means it's going to go into a supernova detonation anytime soon. Here's mighty Orion, the whole constellation. And what you want to look for there is the three stars in its belt. And he is going to look like he's climbing up over the edge of the Earth and heading up into the sky. Now, a little bit further away from Orion, also on early morning, Monday, and for the first couple weeks, you'll be able to see the same thing if you get up early enough. If you trace the arrow of Orion, it'll take you out towards the constellation Pisces. All right. And in that direction is the comet that NASA has studied and observed. Now we're going to talk about this Comet 81P, also known as Wild 2. Right. And if you're out early in the morning looking east, and if you have a really good telescope, right now it's not very bright. Orion you can see clear as a bell, but this one you'd need a good telescope, but it's out there and it's important for us. We're going to be talking about it a lot. Now here's a a perspective view of 81P, wild 2. And if you look at this closely, let me blow this up a little bit. Um, all right, here we go. If you can see down here, there's 81 wild 2, 81P wild 2. And then down over here, Mars and Earth. And you can see the other planets, well, almost all of them. Mercury, Venus, you can see the sun down at the middle. And Jupiter and Saturn right now, they're off to the upper right in this diagram. All right, now, if you draw a line from Earth past Mars, it'll go pretty much right to Wilds 2. Right, so if you're looking at Mars in the night sky, which you can see, Mars looks very bright and red. It's noticeably red, uh, especially if it's still dark out. You can see the redness. And just a little bit to the right of that, no, I think a little bit to the left of that will be Comet 81P Wild 2. All right, now a couple things I want to mention about this diagram while we're at it. If you consider the Sun to Earth distance as one unit of distance, then the Sun to Jupiter distance would be about 5.204 of those units. Now we can measure the distance to Jupiter by triangulation, various methods and stuff. So we know its distance pretty well. And it's about 5.204 times further out from the sun than we are. Right? Saturn's a little further. Mars is a little bit closer. Mars is about 1.5. Now, if you look at this diagram, you can see that Wild 2 is a little bit, it's on this magenta orbit. All right. So it's dipped inside Jupiter's orbit just a little bit, right? So that means that the distance from the sun to 81P is about 5.1 units. And by the way, this distance unit is called the astronomical unit, and we abbreviate it AU. And we'll be talking about astronomical units this semester. It's good for measuring distances in the solar system. And back in the old days, before we could triangulate very well, and before we had radar and lasers and stuff like that, spacecraft, um, they worked out all the distances proportional to the astronomical unit. And so I'm talking about guys like Kepler and Galileo and Sir Isaac Newton and those cats. All right. Now, this website is a cool website. So here's the address, theskylive.com. And if you go there, you'll be able to look up 81P Wild 2 and a bunch of other stuff. It's pretty nice. All right. Now, getting back to our view of the eastern sky in the early morning. Up here's Comet Wild 2. And actually, if you look carefully, you'll see that there's two purples up there. And that second one is red Mars. So if you're looking, you're down at Cocoa Beach or somewhere else, you can look off to the east in the early morning, you will be able to see Mars. And just know that out in that same direction, a little bit further out, is Comet Wild 2. Now, before we go and talk about why Wild 2 is so important, let me give you this website. This is the really, really cool one. It's called inthesky.org, and skymap.php is the page. And you can set this up to look at the sky at any time of the day or night from any location on the Earth. So right now this is set for Orlando, but you can set it to, if you're doing this semester in London, England, you can set it to London, England. If you're out in California, out in San Diego or something, you can set the location to San Diego. If you're out in the Philippine Islands, you can set it to any city in the Philippine Islands that you care to locate yourself at. And you'll be able to look at the stars. They won't show up at the same times as here in Florida, but you'll be able to map them out and see when they are visible. stuff. So it's a pretty cool website. Now, as I mentioned, why are we talking about red giant stars like Betelgeuse and comets? Well, as I mentioned, Betelgeuse we think might go into a supernova detonation. It won't harm us here on Earth. It'll be very visible though, but it won't harm us here on Earth. And we don't know when it's going to happen. It could be now. It could be a million years from now. That's the time scale that you're working with stars. But it's looking a little shaky, so we think it might happen sometime soon. The next 200 or 300,000 years. Anyways, if it goes into a supernova, it's going to detonate, and it's going to look like this. Right now, this is a supernova remnant, and this is the supernova that was observed in the year 1604 as a super bright star by Johannes Kepler, the famous astronomer, and he did it with his naked eye, so that's pretty cool. Now, this is a false color X-ray image. So we have a couple X-ray satellites that have X-ray telescopes and look at stars and galaxies and stuff, and then we make a false color image of it. Here's a composite image combining infrared and this is false color, infrared in red, visible light in yellow. The green and the blue are X-rays. So this is kind of a combo picture of that same supernova remnant. Okay, and it's pretty cool. And now that's what happens to stars. And as I mentioned in the course description, we want to know about the evolution of stars and supernovas and black holes, because that's what happens to a lot of stars after they have evolved to the end of their lifetime. Okay. Now, what does that have to do with Comet Wild 2? Well, let's get to that now. Here's a picture on the left of Comet Wild 2. It never gets too close to the sun. It doesn't even get as close as Earth's orbit. So it never really gets to be really super bright, like the recent one that we had this summer, where you could see it with your naked eye. But with a good telescope, you can view it and photograph it and stuff. This is what it looks like. The nice thing about it is it's close. It never gets much further away than Jupiter, which sounds kind of weird, I mean, Jupiter's millions of miles away, right? But for us now, we get something out to Jupiter is not a big problem. We know how to do it, and we've done it. Yeah, so it's pretty close. And we've sent a spacecraft called Stardust in the year 2000. By the year 2006, it had visited Comet 281P Wild 2 and taken samples. It flew right through the tail of the comet. Now, this little thing here looks like a tennis racket. Yeah, that's the collecting device. Here's a close-up of it in the lab before they sent it up. It's this aluminum structure, and those little rectangular bins are filled with something called aerogel. And the aerogel is where they hope to collect, stuff gets embedded in the aerogel, pieces of stardust from the tail of the comet. Well, let's get down to the nitty gritty here. They found a ton of stuff in the aerogel. There's no doubt about that. But here's the most interesting thing. Some of the stuff that collided with the collector didn't get into the aerogel. It blazed into the metal part, the metal framework, the aluminum framework, and blew bullet holes through it, because they're going really fast, right? And so here's a picture in the upper left of a bullet hole looked at through a microscope, and there's a little bit of residue there, right there. Right, so they're looking at this bullet hole. They got all the aerogel analyzed and stuff. And now they're looking at the debris caked up onto the framework of the aluminum and in near the bullet holes, the stuff that actually penetrates it. So they're looking at this little scrap of residue and they think, let me look at that a little bit closer. And then they analyze the radioactive um, nuclei of that little teeny piece of material there. Here's where it shows up on the isotopes chart. This is the oxygen 17 isotopes chart. It's in red, this little teeny dot, that little spot from near the bullet hole. It showed up amazingly hot in uh, oxygen 17, the oxygen 17 isotope. And the result of that was this conclusion. And this is what brings it all together. The isotopic composition of that spot, that little speck, for pre-solar oxide and silicate grains belonging to group 1 is thought to originate in red giant or asymptotic giant branch stars. So in other words, we went looking for comets, we went comet hunting in the solar system with the Stardust spacecraft, the tennis racket set up with aerogel and everything, getting the tail of the comet, Stardust collected out of all that debris streaming out from the back of the comet. Yeah, and they got there. They got it. They captured a lot of stuff, and they also tracked down the remnant of another star, a nearby red giant star, probably similar to Betelgeuse, that blew itself apart as a supernova billions of years ago, and from which our solar system and probably us are made. We're probably made from the remnants of that star and probably others, a few other stars as well. And so it's kind of cool. So this whole thing, Katherine Johnson for NASA, computing trajectories. If she was still working at NASA, she might have been working on the Stardust program, computing the trajectory. Now that would be tricky, you know, uh, uh, sending a little teeny spacecraft out to a comet and fly through the tail without getting lost, and then bringing it back to Earth and getting the samples parachuted back to Earth. That takes talent, and this is why it it was a surprise, and it gave us insight into the entire history of our solar system. So you might be saying to yourself, how do we know all that about a teeny speck of oxygen from a comet's tail? Well, the way that we know that is because we've studied all the stuff in the course description. All right. So Kepler's 3 laws of planetary motion, yeah, they had to know all about that in order to get the stardust sample. The structure of the solar system, of course, they had to know, where to find this comet and so forth, how fast it was going, what kind of orbit it had. They had to know about nuclear isotopes, and we will too. For instance, the nuclear isotopes in moon rocks and in the oceans of Earth, both of which contain a lot of oxygen. They have to know about thermonuclear fusion, and that's what powers stars. Okay, and and of course, the thermonuclear core of a star eventually goes into a supernova detonation, from which we get those pre-solar grains. They're so rich in oxygen 17. And then, of course, black holes. It's possible that the star that blew up and left that little teeny chunk of oxygen in all the way over in our solar system, it could be a black hole. It could have become a black hole. It could have gone into a supernova and then collapsed all the way down to a black hole. We don't know yet, but maybe one day we'll figure it out. And we do it by studying all the stuff in Astronomy 2002. So that's why we study it. All right, and hopefully we'll also get some insight by stargazing, which is why I tried to map out the stargazing for Orion and the Pleiades and so forth, Mars and whatnot. Now, I'm sure everybody's worried about, how am I going to get a grade? I want to ace this class. So let's get into the nuts and bolts of the semester now that we've got this kind of unifying idea to work on for the whole semester. You're going to be listening to lectures that I recorded in spring of 2018 in YouTube. And there's a playlist that's linked to the homepage and the mission control page. And there's over 28 meetings. And there's a few bonus lectures in there as well. Uh, every semester, I make a few new lectures, including this one. It's not a lecture, but it's a getting started video. But that'll be in the Astronomy 2002 Extra Fall 2020 playlist. So there'll be two playlists. Mostly you'll be looking at lectures in the spring 2018 playlist. All right. Now, we were making plans for me to make new recordings of lectures this semester, and that was all shot to pieces by the coronavirus. So, nobody's lecturing. Nobody's doing any Astronomy 2002 lectures. Otherwise, you'd be listening to me in lecture hall, and I'd be recording them for the next few semesters. But anyway, so this is what we've got, and they're pretty good, and you can learn a lot from them. Also, let me just emphasize that the lectures are the primary source of information for you as a student. Now, the things that we also study are second in importance. For instance, the textbook. Now, we have a free OpenStax textbook. It is pretty good. All right, and you go to it through modules. Here's what it looks like. And if you open it up, it'll look like this. I think this is the title page. And then, you go in through the chapters and so forth. It works really nice. And I have all kinds of annotations and side notes and highlights already in there to kind of give you extra direction about the parts of the textbook that I think are important because, I can't lecture and I can't instruct every single sentence in the textbook. So I have to. That's one of the reasons that I'm paid so much money because I have to make these decisions about what's important to teach from the astronomy book and what's not. And it's all interesting. I mean, we could spend, take any chapter in the astronomy book and you could spend an entire year just studying that. And astronomers, that's what they do. I mean, some astronomers, all they do is study comets, from chapter 11 or whatever chapter that is, so anyways, so I'm always making those decisions. So that my decisions about what's the important information is in lectures, and then secondarily in the textbook, especially in the annotations. We'll have homework inside of web courses, so you'll want to study that too. And every assignment that you have, we'll have about 20, I think. Some of them will be short, some of them will be longer. There's a whole variety. None of them are the same. And you'll have several attempts to, do the homework and get it all right. And so if you do your homework faithfully, you'll have a good chunk of change for your grade by the end of the semester. Also, in discussions and online office hours, which we'll do in Zoom, you'll be able to talk among yourselves and with me. I don't have a TA for this semester, so it's just me. So you can post questions and discussions or take it up directly in online office hours, and we'll have those every week. And the online office hours, I always record them, so if you miss them, you can go back in and listen and view the recording. It's a video. All right. Our examinations are going to be in web courses. All right. And here's a little slice of the syllabus page. We have 3 midterm exams, and we have a final exam. And we'll be dropping the lowest of your 3 midterm exam scores if you take all 3. And we'll keep the best 2. All right. And we'll be using the Honor Lock proctoring package this semester. All right. To cut down on cheating and stuff like that. Right. Which unfortunately happens. And it seems to work pretty good. And this is what it'll look like. Now, this is for a practice test. I've set up a practice test for everybody so you can see how Honor Lock works. And it won't go into your semester grade or anything, but you'll get, it'll be one question at a time. You'll have a certain amount of time to do it, and it will be proctored by Proctor Hub. Okay, so you'll go through all the procedure of taking a midterm uh, in this practice exam, and the same with the final. All right, and those will be proctored and those exams will count for points. All right, now I'll just instruct you to familiarize yourself with the grade scale, etc., on the syllabus page, which goes out in more detail. And I hope to see you in office hours later in the semester. Welcome aboard.